Hi everyone. I wanted to make a screencast of the PowerPoint that I normally use the first day of class in my face-to-face class so that you can also hear me talk about what's in section 1.1 and 1.2 to give you a great start this quarter. Okay, so section 1.1 and 1.2 are a very basic overview about what statistics is. So there may not seem like there's a lot for you to do yet, but hopefully it'll give you a good idea of kind of what you're going to see this quarter. So let's get started. Section 1.1 are really just some definitions. So first, some basics. One word you're going to be hearing a lot in this class is data. And all data means it's going to be the collection of observations, meaning the numbers or the characteristics that we're collecting from a survey or an experiment. So it's what we're going to be analyzing. Most of the time this will be numbers. So for example, maybe I'd ask each of you for your height. I could take all of your heights and that would be our data if we were trying to find the average height of all statistics students. Okay, so your next question is, what is statistics? What have I gotten myself into this quarter? And your book says that statistics is the science of planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on that data. So the idea is we're going to be getting observations, whether they're measurements or something we've gotten from a survey, and then the whole idea of statistics is how do we make sense of that. Okay, and hopefully going through this class you'll see that statistics is really everywhere. You see it on the news, you can use it to make decisions. It's a big part of your life whether you know it or not. Okay, the next thing we just need to talk about is what is a population. And the definition of a population is all individuals, whether it's people or whatever you're studying, maybe it's frogs or trees or whatever you're studying, it's all of them. So this can change depending on what context you're in. So for example, if I wanted to know something about all Americans, the population would be everybody who lives in America. And if the population was just COTC students, then if that's what we want to do a study on, then a population would just be all COTC students. Okay. Now, the other thing we'll talk about is whether we're taking a census or a sample. And a census means that you're studying everybody in the population. And you've probably heard of the United States Census. Every 10 years they try to go out and get information from everybody who lives in the United States. Now, most of the time a census is very hard to get unless you have a small population. For example, if our population was just all statistics students at COTC, that wouldn't be too hard to sample all of you. But for things like, everyone in the United States or everyone in the world, a census would be very difficult. So oftentimes what we do is we take a sample. We just look at some of the population, some of the people or things, and try to make and find out information about everyone, the whole population, based on just some people. So most of the time we'll be talking about a sample, but it's always important to know whether you're talking about a whole population or just a sample. Okay, so that's really all there was in 1.1. I just want to make sure we're all on the same page with those definitions. And now we'll get into 1.2, which is all about statistical thinking. So the first thing you might realize about this class is it's not a typical math class. While we're still using MyMathLab like you might have in your other math classes, and you'll still see a lot of numbers, it's going to be a little different. Almost all the problems you'll see will have some sort of context, some real-world application. And so in this class it's a lot more to understand why you're doing something or the reasons behind it rather than just how to do it. So here are some things that our book tells us we need to consider when we're studying statistics. The context of the data, the source of the data, the sampling method, meaning how we got the data, the conclusions, what can we say from that data, and then any practical implications. So we'll kind of go through this and I'll show you some examples so you kind of get a feel for these. Okay, so first we want to know the context of the data. So if I bring up this chart or this table and say, what do you think it means? Or ask you to do something, you might be confused and say, well, I don't even know what those numbers mean, and that's good because you don't know the context, meaning where they came from. So the left-hand side, you probably can guess that those are years. but the right-hand side probably means nothing to you. And one thing that's important for statistics is to know why we're looking at certain data. So this data, if you look at it, is actually the prevalence of smoking among adults age 18 and over. So you'll see that this is the percent, and then here you'll see a 95% confidence interval, which we'll actually learn in chapter 7. So it's stuff you'll see confidence intervals again, but here we have a percent of what population in the United States smoked. Okay, the next thing we need to consider is the source of the data. How was this information obtained? Okay, and the first thing you should always kind of be a little wary of is asking yourself the question, does this source have a reason to be biased? Are they going to gain or benefit from skewing the data in some way, or how they collect the data might skew the results? So for example, would it make a difference to you if the previous slide came from the Center for Disease Control and Prevention, or if it came from a tobacco company? So that's just one thing that you could always think about. A tobacco company might want higher numbers to show that they're important or something, whereas the Center for Disease Control and Prevention is a government agency that would want unbiased data. Okay, the next thing we always want to, the reason we're doing statistics is to come up with a conclusion, come up with what does this data tell us, okay, and what can we imply from the data. And this is one of my all-time favorite graphs, and I think most students remember it for the rest of the class, and it's what's called a scatter plot. And in chapter 10 we'll learn how to make scatter plots. You'll learn how to make them on your calculator, and in chapter 2 we'll talk about them briefly. But you'll see along the x-axis we have the murder rate. So at different times we have the murder rate, and then on the y-axis you see the number of ice creams sold. So each point represents at one time what the murder rate was and how many ice creams were sold. And what you probably notice is these points, as the murders go up, so did the ice cream sales. Now, can we say anything about causation here, meaning did one cause the other? Probably not. I don't think any of us think that the more murders means more ice cream sales, or that people going out and buying a lot of ice cream are causing people to be murdered. What's actually happening here is there's a third factor, right? It just so happens that murder rate is higher in the summer, as is ice cream sales. So sometimes our data can look like there's one thing causing the other, and that's called correlation, but that doesn't mean that one is actually causing the other. So that's something we have to be careful about whenever we're doing statistics. Okay, one thing that's really important, and one thing you'll notice about statistics is it's more practical than, say, algebra. Algebra is very important, but sometimes it can seem very theoretical, and while stats can also get theoretical, it always has a practical idea behind it. And so one thing, if you're doing statistics, what you want to be able to do is say why, tell other people how this would affect their everyday life. Okay, so we could always just give people numbers, but if we don't tell them what it means to them, it's worthless. So this is information from the National Center for Education Statistics, and it's a whole bunch of data about the education level, the average wage, whether you have a high school diploma or a bachelor's degree. And so there was a paragraph preceding this table, and I highlighted the part that was important, that would give you the implication. And it says, in other words, young adults with a bachelor's degree earned more than twice as much as those without a high school diploma or its equivalent in 2009. Okay, so it just shows you, it's telling you, here's the numbers, but what does this actually mean to you? So that's one thing to always keep in mind with statistics. Okay, now one concept that's a little difficult is to understand what statistical significance means. We can get numbers all the time and find things out, but maybe they aren't statistically significant. If we're doing an experiment, maybe we find that more people on a drug get better from their sickness, but maybe that was just by chance. Maybe the actual pill had nothing to do with it. So the definition of something being statistically significant is that if the results from the study are statistically significant if there's a low probability of getting the same results just by chance. And by low probability, kind of as a rough estimate, we normally mean less than 5%. So if the same results could just happen by chance, it wouldn't be statistically significant. But if it's really unlikely to happen, then we would say something's going on here, something's statistically significant. So just kind of a very simple example, if we were flipping a penny, okay, and we flipped it 10 times, if we got 6 heads, even though that's more than half and we would expect it to be half, we wouldn't think, oh my gosh, this is a crazy penny, right? That would just be pretty normal. But if we flipped it 100 times, it got 99 heads in a row, we'd probably think it was a weighted coin, that something's going on that's unlikely to occur just by chance. Okay, and then the last thing that happens in 1-2 is we talk about practical significance versus statistical significance. So something can be unlikely to occur just by chance, but it may not be practical or may not mean that much to your everyday life. So your book uses this example of weight loss programs where they can show that the average weight loss after a year was 2 pounds. And this was statistically significant because it would be very unlikely for their test people to lose 2.1 pounds just on their own. But if someone's signing up for a weight loss program, practically they probably want to lose more than 2 pounds in just a year. Okay, so this would have, statistically it would be significant. It's not likely to happen by chance, but it's not always that practical. Okay, so if you have any questions, feel free to email me or watch part of this video again, and I will talk to you later.